Hello everyone and welcome back to this online NPTEL lecture. We have been discussing a lot about aqueous complexation in our last two lectures, and in this particular lecture I am going to teach you how to use one particular software if you want to do speciation. This software is freely available for all students, researchers. It is a freely available software in the internet. So, you can download it and practice it in your system. More details about system specific requirements, you can find it in your in the document for the manual for that software. Now, it is not that only this software is available for speciation studies. There are many other number of softwares. For example, for QC you can use geochemicals, geochemist workbench. There can be you can use a variety of models to see which kind of software fits your research. But this particular software I found it very easy, and for beginners it will be very easy to learn this software, and it has a very user friendly interface. So, it is very easy to understand and how to do the input, look for the output. It does not need any kind of coding background, you do not have to write any code. So, just I will show you the basic steps. Okay. So, speciation, what is speciation? It is a distribution of a particular element in its different chemical forms present in water, right. So, it can be available in its free ionic state, it can be available as in different ionic configurations. So, this distribution is determined by the chemical equilibrium. In the very beginning of the lecture series we talked about chemical equilibrium, and we have to see which species is going to be stable and which species is not going to be stable. Okay. So, determining the chemical equilibrium, we need to state what is the temperature, we need to state what is the pH, we are going to state a variety of other components to see okay, what species will be stable, what species will not be stable. So, you will have the entire concentration will be divided into relative concentrations as free ions, as complexes, or it might be as adsorbed forms. Okay. So, for example, if you are measuring copper, so when we are measuring in a particular we are measuring in a particular instrument where the entire copper gets ionized, and there it is getting measured. But when it is in the dissolved state, neutralized state, then it is not exactly as copper ion. So, it is not as copper 2 plus ions or 1 plus ions, it will behave in the form of a complex. Okay. It will be more stable as a complex. Okay. So, therefore, we need to understand speciation of metals, and it is extremely important for bioavailability studies, right. So, the key aspects of aqueous speciation is the chemical forms. Okay. What chemical forms it is going to be existing, okay. Whether it is going to be in the form of ions or in the form of complex and other molecules or absorbed onto particles. Influencing factors, what factors are going to influence the speciation? Redox will definitely change the speciation, pH is definitely going to change the speciation, and even temperature and presence of other ions is going to change the speciation, because there will be competition for ligands, right. There will be competition. The equilibrium constants, the chemical equilibrium constant for different pairs will be different. So, the more favorable, the more stable a particular species is, that will be the more stable one. Okay. So, there will be a lot of influencing factors. Equilibrium. Okay. So, just like I said, so equilibrium will tell me that which species is going to be the stable species. So, you remember that we did the EH pH diagram, and we said that beyond this pH we are not going to find this species, it will turn into another species, and that will be the more stable species in that stability area. Okay. So, it can change with redox, it can change with pH value, it can change with temperature, it can change with the presence of other ions. And why is this going to be so important? It is going to be so important because it controls the toxicity of metals. Okay. Most elements are toxic in their ionic forms. Okay. And they are bioavailable also in their ionic forms. In as huge complexes, there will not be a lot of bioavailable. Okay. So, their bioavailability will decrease, their toxicity will decrease with the formation of aqueous complexes. Okay. So, when we are going to do a toxicity assessment, a risk assessment, we have to determine the speciation and not the total concentration can be converted into its bioavailable. I see a lot of studies where people just simply take the total concentration and convert it into risk indices, and they will tell okay, so and so system is so polluted in this particular metal. That is with the assumption that the entire metallic concentration is available for bioavailable or uptake. For certain metals it is true, but for other sensitive metals it might not. Okay. So, due to this, even if we say okay, the high concentration of this particular metal will cause a lot of issues in the aquatic system, often we see that it takes a lot of time. Why? Because the concentration to build up, to make it more bioavailable will take time. So, even though the concentration is high, it may be in a species which is not readily available for uptake. So, its bioavailability is low. Therefore, the aquatic flora and the aquatic fauna, they will take time to react to that particular pollutant. Okay. So, a simple example as I have already given is with copper and sulphate, they will hardly be in their free ionic form, they will mostly be in their complex form, that is in aqueous form, or as negative or positively charged ions, that is as complexes. And this distribution of the species depends on the equilibrium constants and their formation reactions. That depends on the solution's temperature, it depends on the pH value, and depends on the PE value, it depends on all these equilibrium constants that we are determining. So, when we have a software, what it does is that it has all these equilibrium constant values pre-calculated. It has this calculated already done and fit into the system. Okay. So, when we give that okay, this is a particular pH, this is a particular temperature, then it will quickly make those calculations based on that particular pH and temperature. So, when we are going to do speciation calculation, these few parameters are extremely important to have data of. One is temperature, second is pH, third is the redox potential, that is you can either have PE value or you can have EH value. And another extremely important is alkalinity value. Okay. How much is the bicarbonate concentration or the carbonate concentration? Again, another important value is the organic matter. If you have any organic load in that particular system, organics will be extremely important feeding data into the modeling system. So, now to do the speciation studies, many types of softwares are there. You can you can look into this software called FreeQC. You can look into this software called but today what we are going, and there can be others also, but today what we are going to learn is this particular software called Visual Mintech. The suitability for Visual Mintech for this course that I found is it's extremely easy to use GUI, the graphical user interface. It's a very easy to use. It doesn't require a lot of information. With whatever information you have, I think you can start doing the work, at least learning the software for learning purpose. You can know this. So let's look into how the interface looks like. Okay, so if you go and check it in the internet, it's a free software. You can easily download it if it if your system permits that. So this is the first user interface that we see. So we have all the parameters, the different types of calculations that Visual Mintech can do. It can not only do speciation, it can do multiple other functions. So based on the functions you can select, okay, if you want to input any of these values, okay, that is there in the top row. But for our speciation calculation, our main input will be here as parameter, and in here, that is pH. If you want to add the ionic strength, if you add the components, if you have organics, for instance, if you are working in a lake, river, seawater, of course organics will be extremely high. Even in very dilute waters such as glacial water and all that, organics is extremely important, and without organics you will always miss a significant component of your metal complexation. So you definitely should have at least a simple DOC value. Otherwise you will entire your speciation calculation can be greatly miscalculated, because then you will only have the inorganic speciation, but your organic speciation will be completely missing. So you should always add organic components when you are working here. Okay, and let's see how this moves. Okay, so the first thing that we are going to do is we are going to specify a few parameters. Okay, so the first thing we are going to top, and we are going to click on parameters. After we click on parameters, we will see there will be 4, 5 different options. First is alkalinity. If you have measured alkalinity, or you have measured from charge balance, please enter the alkalinity value, and enter the PE and the EH value. If you are doing if you have the organic component, you please enter if you have any biotic ligand model that you would like to include in this. Okay, so these few parameters you are going to change here in the first first itself. Second thing that we are going to do is you are going to add all the components. Okay, you go on adding all the components. Okay, whatever you have measured, the metals, okay, the major ions, major cations and major anions, everything you are going to add. Okay, you are going to select one particular value, and then you are going to fill the concentration here, and you will say add to list. Okay, again you will take another, maybe if you want to add chromium, you will go add chromium. Okay, depending on whether it is in third or sixth state, you are going to add the concentration, and you are again going to press add to list. Okay. Then after pressing a few times, you can go back and check. Okay, here you will see this option of view edit list. Okay, if you go and click here, you will be able to see what values you have already added. Okay, you can see if I have just fakely added a few values, okay, of some major cations and some major anions. Okay, so you can go and check that, and after you check you can say back to main menu. Okay, so you get back to the main menu, and I wanted to fix the alkalinity. So, I clicked on the bicarbonate option, and I said that my bicarbonate concentration is 5 mg per liter. This is fake value that I am just showing you for learning. So, again I will click here 5 and I will say OK. Okay. Now, you can have if you want to play with the software, you can see how if you want to adjust it to carbon dioxide AF to pH at 4.5, if it does not matter for you, you can just say normal and click OK. Okay. Then you are again going to choose the parameter and you are going to choose the EH or PE value. So, you can most likely you would have measured that on the site itself. So, using a using a specific probe. Okay. So, you can have a ORP meter. Okay. Using an ORP meter, okay, in a multi-parameter probe or a single parameter probe. Okay, you can measure this ORP value. So, if you are measuring it in PE, you measure you click it and you put that value. I said that my particular ORP value is in EH and it is in MV. So, I said it is 10 MV and I will save it and I will go back to the main menu. Okay. So, if you do not want to include any other redox calculations, you can say that do not perform any redox calculations, okay, or just take a guess for EH and all that. So, accordingly you can save it and you can go back to the main menu. Okay. And here also you can fix the temperature, you can fix the unit, okay, and here there is pH value, and pH also you are going to fix it at a particular value. So, particular value got fixed, I gave 8.5 and then I am going to click this particular function called run mintick. Okay. After I have given all the inputs, so my parameters I gave alkalinity, I gave my EH value, I fixed my this one particular pH value, I fixed my temperature, I fixed the unit that I was using here, I gave all the components that I want to do the speciation for, and everything is ready. And if I have DOC values and other organic compounds, I am going to click there also and I am going to add those values. After everything is added, I am going to run mintick. Okay, you simply go and you click on run mintick, and then what you get is something like this. Okay. So, you will get something like this, where you will get the concentration and aqueous inorganic species, the activity and the log activity values will be given. So, from the concentration you are going to get the activity and of course, the log of the activity value. Okay. Now, from here you are going to get 3 inputs. You will see the species distribution for every element, you can see the saturation indices of the minerals, and you can see the mass distribution, that means how much of it is in the dissolved state. If you add some particulate data also, that will be helpful for that kind of distribution arrangement and all that. But here everything is dissolved, so this will show everything is dissolved state. So, you can check the saturation indices for the minerals and you can see the species distribution. So, what we are going to see is the first thing, here is the saturation indices. Okay. So, this particular thing, okay, the saturation indices. Okay. So, you will see that there are different minerals here. So, there are different minerals here, and you will see okay, which one is saturated, okay, which one is undersaturated, which one is oversaturated. If something is going to be oversaturated, then that will precipitate out, right. So, you need to know okay, which one is precipitating out, which is likely to precipitate, and which will not precipitate because it is undersaturated. And if it is green, it means it is apparently at equilibrium. That means you may not know, it might still be precipitating at some time. It is very close to precipitation and it is at equilibrium. Okay. So, you understand that it whatever is precipitating, it may again get dissolved. So, it is at equilibrium. Okay. So, you are going to check first which one is under saturation and which one is oversaturated. Okay. So, after we check that, and if that helps us understand anything of the dynamics of the system, next what we are going to check is this. This is the equilibrated mass distribution. Okay. So, the distribution between the dissolved phase, sorbed phase and the precipitated phase. And what is extremely important for us is the first option, that is this view species distribution. Okay. This we are going to see like this. Okay. So, if you click that button, you are going to see that your calcium, how much of calcium is going to be in +2 state, in F plus, in CaCl plus form, how much of it is going to be in aqueous form. Okay. So, the different forms that it will be. Okay. So, if you just scroll down, you will see all the elements. So, if you go down, you can just print to Excel and you will see all the elements. For instance, here if manganese is there, it will show every manganese is in the +3 state, but iron is there in 80% is as FeOH2 plus, 4.722% is at FeOH3, which is aqueous. That means it is going to settle down, right. It is in aqueous form, it most likely will get precipitated. So, it is there in the aqueous form, it is neutral and it is most likely going to be precipitated. Okay. Similarly, for nickel, nickel will have so many speciation. Okay. What will be the effective concentration? Now, if I want to calculate okay, the effective nickel threat in a system, what will I see? I will see this percentage. I will see okay, if my nickel is 100 microgram per liter in a particular solution. Okay, if my sample I have 100 microgram liter of nickel, then only 61.61% is in the nickel +2 state. That means it is available for uptake, bioavailable. Okay. So, 61.61 microgram per liter will be my effective concentration for all kind of bioavailability study. That is, you can calculate the toxicity and the risks. Okay. For all those calculation, you are going to use this value. You are not going to use this value. And which particular species you are going to consider, you can look for that. You can tell, you can search okay, for this particular metal nickel, which forms of nickel are most bioavailable. Is it Ni+2, is it NiOH plus, is it NiF plus, is it NiCl plus, whichever comes under this bioavailable form, you can take that. Maybe this NiCl plus form is also bioavailable, then you should add this and this. So, 61 plus 61 plus 0.07, that will be your total percentage for bioavailable. But before this, you have to check certain biology books to find out that which metals will be bioavailable, because if you see, if you have a extremely complex form, okay, if you have extremely complex form, is this available for bioavailability? It will most likely be not. These aqueous forms will most likely be not bioavailable. But this does not mean that they will never be bioavailable. It just means that they will be there in the system. They might have a different fate. They might get settled down with the organic matter, with the sediments. They will slowly get removed from the system through settling down if it is a lake, or if they can move downstream with the water. So, this immediate impact will not go. Okay. So, whenever we are going to do risk study assessment, you always should consider the you should give importance to finding out the speciation, to doing the bioavailability. Okay. Again, it is extremely important. So, the first things you need to know what is the pH, temperature, conditions, extremely important, and these are all in situ. Okay. These are not that the data that you come and measure in the lab, these are the in situ data that you have. Second thing, you should have some organic components. Okay. Okay, you should have the organic components ready. So, either DOC, you can have DON. Okay, some values of organic carbon or organic nitrogen should be there, because this will give you understanding whether you will have the organic ligands. And you can always see that 60 to 70% of speciation will, or sometimes it can actually be 90% of the speciation and complexation will be in with the organic ligands. Okay. So, pH, temperature extremely important, organic components extremely important, PE value or EH value. Okay. EH value, both of them are extremely important. Okay. You either find the EH or either find the PE value. Okay. Redox condition, what is the redox condition? Extremely important. Alkalinity, very important parameter. Okay. Fifth is metal concentrations, correct metal concentrations. Okay, correct metal concentration of all the entire, not very selective. You should have all the major ions, you should have the major, so basically cations and anions, you cannot miss the anions. Okay. And you should have the entire periodic table starting from lithium to the heavy metals, including lead, uranium and all that. Okay. If possible the REs and all that, because they are all fighting for the ligands, they are all fighting for the redox this thing. So, if you are missing values, you are just having more errors in your data. 6 is the which are the bioavailable fractions. Okay. Which species is the bioavailable. Okay. And this is element specific. Okay, this is element specific, and then you can do any kind of speciation study. You can do any kind of speciation study. Okay. So, with this I will come then end to this lecture, and I will see you in the next lecture. Till then, bye. Thank you.